That was awesome. Let me get this straight. So, chemist, master's in material science, LabVIEW programmer, NFL athlete, astronaut on 2 missions, an administrator at NASA. This guy needs to do something with his life. Okay, so we're going to move to the university level now. So a couple of years ago, we introduced myDAQ. And it was a student-inspired device where we wanted to make it possible for students to do engineering anywhere, anytime. Not just in the laboratory or the classroom, but where they could literally take it home and learn about measurement and electronics and circuits. Well, it has been incredibly successful. In the 2 years since we made it available, we've had over 600 universities standardized on myDAQ for everything from intro to engineering all the way up to senior capstone design. Well, we're at it again, and today we're very pleased to be able to literally unleash the LabVIEW RIO architecture on students worldwide. Okay, so here to tell us all about the new NI myRIO, please welcome the myRIO product manager, Margaret Barrett.
Good morning, Ray.
Hi, Margaret.
Hey there. So for years, Ray, we've watched our industry customers do truly incredible things using the LabVIEW RIO architecture. But what we've needed is a way to take that same technology and put it in the hands of students so that they can learn on the same platform that they're going to see when they graduate. But one thing we know is students get just 1 semester to complete a meaningful project. So we set out to create a product that would allow students to design real systems fast. Now, as we thought about this, we thought a lot about final year design courses, but we also thought about classes that students take building up to final year design. Things like embedded systems, controls, robotics, mechatronics, and we took those as inspiration for the features of myRIO. So we knew that myRIO was going to have a lot of I/O. It was going to have I/O that was pre-configured so students could get up and running quickly out of the box, but it was also going to have I/O that could be reconfigured using LabVIEW FPGA if a project required it. We knew that it was going to have to be based on the latest industry technology, so of course students would see it again when they graduate. Of course, we chose the Zinc chip for this, featured in our brand new compact RIO. And we knew that myRIO was going to have to be able to interact with modern technology and be very easy to connect to. And finally, if students were ever going to take this thing outside of the lab, we knew we had to put it in a case and make it small enough to easily fit into a backpack. So that was our hardware, and we were pretty happy with that. But we thought, man, you know, if students can't program this thing, then we failed. So what I want to show you now, Ray, is the real magic of myRIO. It's all about LabVIEW. Let's take a look. All right, so here let me just connect over to my target. And you'll see here, Ray, that I have a LabVIEW block diagram. Let me just cycle power on this guy really quickly here. So I have a LabVIEW block diagram here, and one of the things that you're going to notice right away is that I have an Express VI. Now, it's probably a little bit surprising to a lot of our RIO programmers in the audience today, but we wanted to give students a way to connect to I/O very quickly. But we also wanted to enable them to learn a little bit more about LabVIEW and see some of the more lower level things that they're going to be using when they program in industry. So one of my favorite features about LabVIEW with myRIO here is that if I double-click on any Express VI and I click View Code, the code that is underlying that Express VI is actively scripted in this window. And I'm actually able to take that code, copy it to a clipboard, and paste that onto a LabVIEW block diagram so I can start programming from that point. So let me connect over to this target here, and we'll give this VI a run. So I'm going to run the VI, And it's actually deploying out to myRIO right now. I'm going to run on this target. And in just a second, Ray, I'm going to ask you to give this a little bit of a shake, and we're actually going to take a measurement from the onboard accelerometer that is on myRIO. So I'll take just a second here to deploy. Get in position there, Ray.
Okay. You're not going to shoot anything at me, are you?
No, that's not this demo. All right, so give that a little bit of a shake there. And we're actively taking measurements from the accelerometer there on myRIO. But one of the things I haven't told you there, Ray, is that I actually deployed to this guy totally wirelessly. So I'm going to just give you that battery. Why don't you take a walk across our stage? And you're holding a wireless RIO target, Ray.
Nice.
So, there you go. So of course we're seeing data streamed back to my front panel on my computer here, but I could also use data on Data Dashboard with myRIO. And in fact, I can send data to myRIO with Data Dashboard, so how about I just turn that VI off there, and we're done.
Wow, that's great.
So I think we can see from what we've seen so far that students can design some really cool systems with myRIO, but of course myRIO can be used to teach as well. And I wanted to tell you a little bit about that. So earlier this year, we were able to run an early access program with myRIO and send a few out into the world. One of the places that we were able to send that to was the University of California, Berkeley, where Dr. Edward Lee, who we all know from embedded systems, is actually going to be using myRIO to teach this fall, leveraging both LabVIEW programming and C programming with the Eclipse IDE. But to actually tell us a little bit about how myRIO can be used in mechatronics, I'd love to welcome to the stage from Rice University, Dr. Marcia O'Malley and her students, Chad Rose and James French.
Morning.
Hi there.
Morning.
Hi, guys. Welcome to an iWeek. So, Dr. O'Malley, can you please tell us a little bit about the course that you teach?
Sure, Margaret. I teach a required course for mechanical engineering students at Rice called System Dynamics. This course requires students to develop mathematical models of mechanical and electrical systems based on first principles. Then, students learn several techniques for solving the differential equations and analyzing the time domain response. A key component of the course is the laboratory, where students apply these skills to real-world physical systems. Now, as Ray said earlier, we experience students coming in with prerequisites in calculus and physics, but with very little in terms of hands-on laboratory experience. This presents a real challenge for us. We've used a simple haptic or force feedback device as a centerpiece for our labs, and this system requires students to acquire sensor data in real time and command a motor. About 10 years ago, when we adopted the haptic paddle for our labs, we partnered with National Instruments and selected the PXI platform, coupled with LabVIEW real-time, in order to achieve the closed-loop control rates necessary for good system performance. However, we found that programming and system integration experience necessary to use the PXI, while it was a capable system, was a bit over the heads of our undergraduate students. And we ended up with a lab where the PXI sat there like a black box, TAs would run a demo, and students would sit idle. Not really the engaged laboratory experience we were going for. A few years ago, we were able to add myDAQ to the labs. myDAQ was a great, open, and easy system for our students to use for the early laboratory experiments, which required data acquisition for sensor calibration and motor characterization. However, in the later laboratory experiments later on in the semester, myDAQ didn't have the system specifications necessary for closed-loop control. With myRIO, we are very excited to have a single, accessible platform that we can use for every lab in the course. myRIO is great because it couples the simple accessibility, the out-of-the-box nature of myDAQ, coupled with the performance of NI's RIO architecture. James, can you tell us about your experience with myRIO?
Sure. So not only is this course a first experience with LabVIEW for our undergraduate students, but also we're pretty sure that David, the Lego guy, had more experience with LabVIEW than Chad or I did last fall. So one thing that helped with our transition to becoming lab teaching assistants was that LabVIEW was really easy to learn, and we were able to understand the VIs that were handed to us by the previous generation of lab TAs. One thing we really liked about LabVIEW is that we were able to use, for example, a formula node in which we felt more comfortable scripting as from our previous programming experience. And that also allowed us to provide our students with an easy input to implement their own control algorithms. Now, if we fast forward from the fall to the spring semester, when Chad and I were tasked with upgrading our labs with the myRIO, we found that the migration from the myDAQ to the myRIO was seamless and easier than it really should have been. LabVIEW 2013 comes with express VIs that looked very similar to what we were used to based on our experience with the myDAQ. And there was no need for us to program the myRIO FPGA as it came pre-configured with the performance we needed right out of the box. So Chad will tell us a little bit more about our haptic paddle system.
So like Dr. O'Malley was saying, we use the haptic paddle, a simple 1 degree of freedom mechatronic device, to give the students some hands-on experience with the system dynamics that they studied in the course. So the haptic paddle is really simple. It has a DC motor for actuation, a Hall effect sensor and permanent magnet for sensing the position of the paddle, and the students use the top of the paddle as their user interface. Over the course of the semester, the students build up to the final point where they combine 2 of these systems, and they perform teleoperation. So the first type of teleoperation that we show the students is unilateral communication, and that's where you have a master and a slave paddle. The students input a position on the master, and that is relayed to the slave, and it follows. However, there's no feedback from the slave back to the master, so you don't really know what's happening in your remote environment. The second type we show is bilateral communication teleoperation. That, instead of having a rigidly defined master and a slave, both paddles send and receive information. So the students input a position on the first paddle, and the second paddle tries to follow, but if, for example, there's an obstacle or a viscous field in the way, this first paddle would realize what's happening in the second one. So James, why don't you pull up the VI so we can show everybody what the students actually see?
Sure. So on our front panel, we've included some information that we find useful for our students. On the right, we're showing position readouts of each paddle over time so that the students can see the system responses that we're trying to teach them. In addition, we have control signals that we're sending to each haptic paddle below that. And on the left, in the yellow, are control parameters that the students can change in order to change the system dynamics and see the responses.
So first, let's look at unilateral communication. So it's already up and running. Excellent. So the students have their master and their slave. They input their position, and the second one follows. But I don't have any feedback on my left hand what my right hand's doing. So if we engage the bilateral communication, I have the same response, but I have feedback. I can feel what's actually happening on the remote system. So the great thing about the haptic paddle, instead of just being able to do teleoperation, which in and of itself is pretty cool, we can show the students a lot of other things, like, for example, a virtual wall, a common benchmark for evaluating the performance of a haptic system. So with just a simple click of a button on our VI, we show our students the the virtual wall. So what's great is on this side, nothing's happening, and the walls here are set at 3 degrees, so students can come in and feel it. And then on the fly, they can change the control gains to see the performance increase or degradation based on their choices, and they can start to see their first and second order responses.
Wow, that's incredible. How about a big hand for this? So, I really appreciate all you've done. It's amazing in just a short time since we're beta testing it, what you've accomplished. Obviously, we're very excited about the future for myRIO. Thank y'all.
Thanks, Ray.
Thanks, Ray.